There we go. I muted the microphone. That would have been a very boring live stream. Okay. So let's me introduce what we're doing today. We are trying to fix the BRDF. So this is our fragment shader code that we need to that I need to go over. We do have a little bit of we did correct it a little bit, but it's not really up to par where it needs to be honest. So our BRDF is just a combination, our specular BRDF is just a combination of 3 functions. And the problem is I kind of just winged it. Here's our specular BRDF, for the most part anyway. But I've been sent a resource which seems to be way better at producing accurate results when it comes to lighting. I'll just say hello to everyone in the YouTube chat. Also, if anyone's watching this, I very much appreciate anyone who has subscribed recently or liked the new video. I very much expected that. I didn't expect that video to do well at all, to be honest. I was kind of, funnily enough, I almost gave up on making it. Because I thought I hadn't worked hard enough that year, so, or at least made some progress. So this is what we're going to try and do anyway. It's basically this, where we combine these 3 functions together, do some specular. No, that's actually what this is actually the maths we're going to try. It does say though that the lighting needs to be done after the BRDFs combined, the Fernal, the G specular, and the normal distribution functions. So once they've been worked out, we basically combine them all together and the Fernal. Is that the Fernal? No, that was the Fernal, sorry. This is just the Lambertian function. So let's get the Lambertian function. I'm not exactly sure what everything does, but you know, a lot of the live streams is just me figuring stuff out on the fly, so thanks, man. Yeah. Thanks for watching the video. I hope you're having a good day, my guy. So yeah, we're gonna do lighting. Lighting today in our fragment shader, which is a bit primitive. So I think, yes. I think what I'm gonna do is remove the light, try and get my physically based renderer working, just so people can see what the issue is. So when I have one light, it looks fine, like here. But when I move to here, you can see a lot of like questionable things happening, which, you know, assuming this place is that dark, we shouldn't be seeing any of this, right? We're literally seeing the base color. I just wonder if before we do that, before we even start, I wonder if this is the actual culprit, which would be interesting to see. I just wonder if it's like too dark. Okay, interesting. What on earth? Yeah, okay. Ah, we've got junk data. This is junk. It looks cool though. It's kind of like a... Yeah. Yeah, that's just junk. Okay, so we're basically picking up junk data there. So yeah, what I want to do is effectively recreate this this summary here. Yeah, pretty cool, right? Pretty nuts. So we're trying to recreate this guy. I have read over this before I started the live stream. but I won't know everything off the top of my head, so I'm going to probably refer to this quite frequently and see what's what. I've also got to make sure that I don't, for the parameters that I'm passing in for this, you know, for the textures and all that kind of stuff, I've got to make sure that I get everything kind of right before I begin running the calculating the BRDF. So yeah, that's the first step. Make sure that the parameters match up with these guys here. So because I can't just assume that I have n dot h, for example, if I don't have, you know, do I have n dot h here? I don't think I do. N dot l, n dot v, n dot lv. Okay, so yeah. So I've got to make sure that I've got like the same ideas going on. Yeah. So the first thing I'm going to do is remove the lighting. Remove the light from this. So this is the final like 3 guys, I think. And yeah, so we're gonna try and work this. I know. Yeah. Okay, 0.4. Just trying to remind myself what I actually did here. So, all right, we can at least, I think, write a function in the shader that does one of these better than I'm currently doing. So, like, I just need to nail down which one I want to do first. Yeah, first let's get rid of the lights, though. Okay, so that's the lights, I think. I am multiplying the... Yeah, okay, so I've turned off the lights. So it's just... everything's kind of matte. You know, everything's the same brightness. Because everything has the same intensity, which is fine. Alright. So our first idea is... I might... because I hate copy and pasting code, because I find it kind of cheap. I'm going to try and just kind of do this. Hopefully that doesn't annoy people, me coding like this. So we have an encode. This is just to move out of linear and non-linear space. So we can do operations within that. So this is the... So what is he doing here? So he gets to be... So this is to build up the specular. Alright, let's build up the diffuse, right? Diffuse is probably the simplest, because it only has one function, which is literally just 1 over pi times the diffuse color. And so this is the base color. This is our diffuse color. Alright, so currently this is exactly the same, I think. Weirdly, it's the multiple... yeah. Yeah. Just because the distributive multiplication law of scalars means that this doesn't matter. This is exactly the same. So it looks like my D and V is either distribution or this. So alpha squared, that looks like this. So this is our G. And G is made up from... yeah, because we have alpha, alpha. Okay, and then we have this thing. One thing I don't really like about... I mean, I love the work that these guys put in. I just hate the fact that, like, mathematician types always name variables of 1 letter. So it's like, you know, what does this mean? What's A? Anyway. Okay. So alpha makes up this distribution. Yeah, okay, so this looks like... yeah. So we have this denominator, denominator. Multiply by pi. Okay, and then we have this. So this is all part of the DGDX, which I can't remember off the top of my head what that is. So the distribution, I wonder if the distribution is fine. Okay, let's see. So it takes in 2 arguments. It takes in the alpha, which we have. N.H. Ah, there's N.H. So N.H times by okay, so there's a bit of arithmetic change here, but if I'm squaring, I mean, I could literally rearrange this, but I highly doubt that the algebra is any different. I mean, I could try it. So alpha squared -1 I have no idea what's more efficient. I'm assuming it's all the same. Actually, this is 3 multiplications of n.n, and this is... Oh, I see what I've done. I'm multiplying this and this together, and then kind of working out what that is, I think. Alright, let's just... I'm kind of just going to move stuff about and see what happens. Do some algebra shuffling. Because that's what they're doing. And then you just have n.n again. Right. I can't imagine that makes any difference at all. I'll be very... Oh. One thing about Visual Studio is I never remember how to run a function. How do I run a program? With a keyboard shortcut. Yeah. Yeah. I feel like obviously the people who worked this out were all mathematicians. And they weren't programmers. Yeah. F5, brilliant. Also struggling with Vulkan. Hey Adam. Hope you're having a good day. Well, hopefully it struggles with Vulkan. Brilliant. Thanks for the reminder. End up going away. I know you're doing a lot of work, so you know I see what you're doing. Yeah, so the distribution doesn't... Yeah, I don't think there's any difference here. Oh, right, okay. You're also doing... Are you doing physically based rendering as well? For you to diffuse... are you talking about specular BRDF and all that kind of stuff that I'm working on? Alright. Okay, so we got that. Ah, okay. I think this V is visibility, yeah. And we just need F, really. So what is V in this crazy town? V. Okay, so specular blah blah. Smith, it's the Smith function. Smith. Okay, so we were using that. And this is for what, visibility? Yeah, I think so. Oh, you're talking about local AI. Oh, of course, diffuse video. Sorry, I'm in graphics. Diffuse means obviously something completely different in AI. That's funny that. Yeah, so this is just right. I'm gonna. Okay, so visibility. Interestingly enough, they don't really have a if statement here. I wonder if I can get rid of it as well. Don't worry about it. It is what it is. Well, hopefully you sort out your local AI and stuff like that. That's something I've never learned about. Okie dokie. So we have a lot going on here. So this uses squared alpha. Okay, it's the first variable. I think this is pretty one-to-one. Again, I think there's just the algebra's been moved around. I don't think there's any difference here, apart from heavy side being used, which is just... Are we just trying to stop a division? I'm going to rewrite this visibility, but I'm just going to start again. Just because it's a bit... If I start working with what's already there, I'm going to end up kind of... yeah, let's do exactly what they've done, because I want to make sure that I get this right. Comfy Yui. Is that what that says? It's simple and fun to play with. Right, okay. Interesting. I assume that's all AI related. Oh, comfy UI. Okay. That times by squared. Right, let's just see what we can do with this. Alright, I'm going to literally just air quotes plagiarize this. Even though it's technically public, so. Alpha squared plus n dot l. I have n dot l, great. Times by n dot l plus alpha squared. Okay, so you don't like that, why? Oh, I literally don't have these variables. Oh, I literally call them n dot l. For goodness sake. Brain fart right there. And no, and NOV. Oh, there it is. N dot V. N dot V. Okay. So now we have that. I assume this is extremely similar, so I'm just going to take this, change this to V. Okay, N dot V. I think what's happening here as well is the reason that they don't have an if statement is because they're guarding against that with this variable at the beginning. A step, okay. Sounds cool. I'll look into if I start learning AI. I will keep that in mind. I'm not that interested in AI right now. But you know, I really much appreciate you letting me know anyway. Okay. I'm really interested in computer graphics. It depends how much experience you have in programming already. Alan, if you're interested in computer graphics and you want to code some graphics, sometimes the best place to start is like just learning how to code better. I know it seems kind of boring to say that. Like, it depends. Like, if you're not afraid of the maths, it's cool. That's good. That's a really good start. Like, this probably isn't intimidating to you at all, which is brilliant. But it's also like, you don't want to get tripped up and get very frustrated with like C++, for example. I don't know what language you would want to pick for this, but you know, sometimes learning the basics of C++ will just help you in the long run and stop you getting frustrated. If you're already like a good programmer, is it visibility? Visibility. Then yeah, what would I suggest? Now, I like Vulkan a lot. People say it's really, really difficult, considering you have to do a lot of the graphics driver overhead. I would say that if you're really determined, the upside of learning Vulkan is that you get an actual picture into what the CPU is doing. Sorry, what the GPU is doing. So, let's have a look. What did that look like? And we have... So, Vulkan is really good in that sense. It also depends like what graphics you want to do. Like sometimes it like you might be just interested in the shaders. Okay, cool. It also like it's possible that you just could be Are you interested in coding a game engine? Do you just want to make shaders? Like technical artists exist, for example. They just all they do is they write shaders for engines, and they don't have to worry about Vulkan. They don't have to worry about anything like that. So that's also an option. Right. So we want F now. So yeah, it really much depends on your goals, to be honest. What is F? Slick. I think this is like the simplest one. Oh, okay, so this is the... So I think I do this here, right? The Fernal mix. And I just use 1 plus this. Interesting. This is not the same at all. Oh, it's this line. So I'm using a float. Interesting. Okay, let's give that a shot. Let's write another F slick. I forgot what this is called. Give me a second. I would say though, if you want to literally start with Vulkan, Vulkan is fantastic in many different ways, but it's also very frustrating in many different ways. I would go with How to Vulkan. Is a great taste into what you should learn. It's written by the same guy who wrote the original Vulkan tutorial, but it's like way shorter. It skips a bunch of nonsense by just giving you a bunch of libraries straight off the bat and just says, you know, it just says go. Its whole goal is to get you to render like a pretty model as fast as possible without explaining too much, so it doesn't explain everything in detail. So you won't become like an expert by the end of this tutorial, but it'll be a good like taste, right? It'll be a good like, okay, I can see myself learning more Vulkan in the future to do more advanced graphics. Yes, that's the one. That's exactly what it is. Hi TT. Glad you can catch the stream. Hope you're having a good day. No problem. Yeah, good luck with that. Hopefully it's useful. Where is this? Okay, this is what I was after. So that's simplified if, yeah, we have an approximation. So we mix BRDF, specular. I wonder why we do that. That's different from this, right? It's funny, we'll code all this and everything will be the same. Well, I'm trying to understand this. So it builds up the specular, which is a bit different because that does it up here. Because we're doing like, this is the equivalent of doing D and V, but we're not multiplying by F. And we're getting a, we're not having a vector. Ah, okay, so it looks like the D and V are, yeah, these are scalars and this is a vector. So this actually scales the vector. And then we can apply the lighting, which we did here. This is the lighting. If we have the intensity worked up. But I got told by someone yesterday, no, on Thursday, that it's good to apply the lighting after we've combined the specular, after we've created the BRDFs completely, right? So I'm going to try and do that. I'm going to try and set the intensity up. So we'll see how that goes. Okay, so yeah, this just mixes everything. And then what's this phenol mix? Or fentanyl mix? I don't know. It just makes the materials. And then, yeah, based on 2 other textures, emission and occlusion, we do something different. Okay. Wait, as well. Oh, I was just looking at the I don't know what that's. I don't know how to read that. Yeah. Friend Nell. Okay, Fresnel. Okay, Fresnel. Thank you. Yep. Right. Okay. Thanks, gang. Right, let's just see. We have a F0, which is, yeah, we have F0. Let's just say FR, right? And this is going to break this, so I'm going to comment that out for a minute. Okay, yeah, so one step at a time. Yes, we want diffuse to be, yeah, so we got diffuse. Conductor, which is the, what? Hang on, give me a sec. What's the conductor again? I'm gonna have to scroll through this. What formula was I using? No, I haven't heard of. Hi, Relics. Hope you're having a good day. No, I haven't heard about S-slang. Is that some shader language thing? S. So, what am I doing here? I think the reason I'm a bit confused by this is because this is unfortunately just word of mouth. I have copied this from a book like in 2023 and never really looked back. So we are kind of we have some kind of like physically based render that does need improvement. So some of this stuff will be a bit like, what was happening? Yeah, conductors. Mm-hmm. Hmm. Oh, okay. Just another shader language. I haven't felt the need to move out of GLSL before. For now, I'm kind of happy with GLSL. But you know what? I've been looking into KXT today. Is it KXT? The texture, or KTX. I can't exactly remember. The texture thing. Let me just Google that quick. KTX. Right. Nope. What is the what's the textures thing? Yeah, KTX. That was right. Okay. It does seem interesting. It doesn't seem. So yeah, I am looking into more Chronos tech. Basically, that's why I brought that up. But let's puzzle through this. So we have a. Okay, so the Fresnel function can be seen as an interpolation between the incident speculation reflectance and the reflectance grazing angle represented by F90. Observation of real-world materials shows that both dielectrics and conductors exhibit achromatic speculation, reflectance at glazing angles, and the Fresnel reflectance is 1 at 90 degrees. A more correct F90 is discussed in the section. Okay. Give me a sec. Using F90 set to 1 approximates the okay, so I think this is this part of the function, right? U is just h dot v. That's the F. Then I just don't see the. I don't understand why the specular BRDF is in here in this function. Now let me just see what this is used in. Okay, so this is mixing. Okay. Okay, let's just comment this out for a minute, because if we can get around using a limited... I didn't like that. A limited number of things to get the same results, that might be better. Sasha Williams has updated all his... Oh, is he updated his to S-Lang? Oh, okay, so he's using that instead. And how to Vulkan. Ah, right. Admittedly, I have just been reading it as revision. I haven't actually got to the shaders part yet. That's good to know. Yeah. I think I'm revising up to here. Ah, here we go. Right, okay, yeah, so there's... Yeah, there's probably something going on here that's... Oh, yeah, there we go. Got ya. Alright, right, let's write this 100% exactly the same. So it looks like we're doing a little extra here, kind of like... I think we've simplified this quite a lot. Apply lighting. Question is, from this point on here, this is just a BRDF, like how do we actually get the final color out? Is this the material color? No, this is just a diffuse. Then we mix them together here with this guy. Choose a vector. Alright, I'm gonna kind of uncomment stuff and kind of like see what the displays of each of these values are. Because right now off the top of my head I don't actually know what this should be. So what is it? If I have, it could be all black because we don't actually have any water or high reflectance, but I'm kind of curious, right? Back 4. Yeah, let's do that again. So that just decodes it into a color space that makes sense. Into linear. Nothing crazy. Right, okay, so yeah. Right, let's just see what that looks like. F5. Yeah, relics. I've never heard of that. What is it? Is it interesting? So this is the materials applied with no. Huh. Weird. With no metallics. So there's. So the metallics isn't worked out, I think. Yeah. The Spartan engine. Is that your engine? The Spartan engine? Are you developing that? So it's another experimental game engine. Cool. Yeah, you know what? I'll have a little Google of that after the stream. No, I'm a bit kerfuffled here. What is this then? I mean, this is probably going to look terrible. I have no idea what this is going to turn out to be. F5. This could be all black for all I know. Okay. Interesting. So this is... So we definitely have the metallic stuff here. That's that. Okay. Why does that happen? Yeah, this is like the conductor. It's just like how metallic something is. But on matte materials, we're getting like a gloopy, gross look. Okay, going forward. What is... No, I know that... I don't think this has any occlusion. I don't think it has any emission. For anything. So the material color is what we had. Okay, metalness, kind of curious. This is probably just a float. So this just is a lerp, I think, between the three. Yeah, what does that actually do? Let me Google. Mix. Bro, yes, I'm still watching. Yeah, okay, so linear interpolates between two values. Start range. So they're the values to interpolate between x and y. And these are the two vectors that we're interpolating between. Okay. Right, okay, so that makes sense. Okay. I'm gonna try something. I'm gonna try the V. Do I have that? I kind of just V dot hang on dot. Yes, there it is. Where are you? Oh, there it is. Going blind. Okay. So this isn't clamp. This is the absolute. Okay, I'm going to try doing that version because it is doing a lot less work, right? We don't have this if statement. All right, get rid of this for a minute. So I'm just gonna test what is the difference between these two if I remove the if statement. We could get complete junk being read to the. So abs dot n yes v plus. I think I had this in an if statement, but I think I can do that in a shader. So it looks like to me this and this can be just deleted when we have this here. So I don't know what this is going to do. F5. Interesting. Okay, so that is actually black. I think we've got actual blackness. Like true darkness, right? I mean, I'll have to add in a light, but yeah, we don't have that weird, like, when it goes 100% black, it goes to the base color. Okay. To me, this already looks a little better. I kind of, I mean, obviously you don't want straight black when you're working with games at all. But I think that's like, you work on top of this as like, you know, you would add a light here or something. Or you would have some global illumination type deal. Or just some, like, you know, skylight basically or something. I don't know. Yes. Yeah, shaders can be quite testing. Although at least I'm not working with I'm not dealing with Vulkan validation errors yet. I say yet because that is definitely going to happen at some point in the future. Yeah, why do I have that if statement exactly? That's what I've been thinking. Like, I can just remove it. And I think it's like you don't want if state. You would obviously want as much. You don't want branchless code in something as dense as the fragment shader, really. But anyway, I want to add a light back in just to see what that does. That was here. And here last time, I remember. Nope, that wasn't here. Where were you then? Oh, it's just multiplication. Okay, so yeah, that doesn't matter. I'm just saying do the visibility in that first. That could be the wrong multiplication, but we'll see. Oh, yeah, I was staring at black. Okay, that is a lot better. That legit looks like how would I expect it if we had one light in the scene with nothing else? We have no way to control this light yet, because there's no just like uniform or push constants. So I've just kind of like randomly, you know, thrown it in the middle. But that looks a lot nicer in my opinion. Obviously we still got transparency, which is making things look ugly, but you know, whatever. I think this looks better than it did before, at least. Right, okay, so it was, I think before it was taking... I think before it was all glossy, as you were taking the inverse of the roughness and the metallic channels. Ah, interesting. That's a good way to fake glossy surfaces. That's really interesting. That's me adding the lighting after the fact. Okay. What do I want to do next then? So kind of solved the problem that I was kind of having. I didn't like the fact that everything was going weird. I do have a question, like what is the difference between these two? So if I bring back this visibility with heavy side kind of thrown in there, that doesn't let it go below a particular point for the dot product. I hate when I do that. Okay, so experiment. So we've got visibility. See what our specular looks like after that. I'm gonna have to go. Give me a second. Let me just go back and see what happened. I honestly think a lot of this is just the same as this, but just like the algebra's been switched around. Like I don't see that much difference when I actually looked at the code. F5. This might be more accurate, the one I've chosen. I mean, with the lighting, we're constantly turning up the intensity at wherever the light is, and you can obviously see that with the intensity turned up to basically 100, we just basically get white, and then black, like sharp black, which isn't. I don't think that's correct. But I guess it's a really cheap way to make a light. Just kind of scale it back from 0 to 100 based on the intensity. We do have something going on here. We're not just like throwing in a variable and multiplying all the values by something. I'm multiplying n.l too late. Oh, yeah. Why did I do that? I think I was on stream and I thought that's what you wanted a long time, like a while ago. Like, that needs to be done. Where do I put this again? This is here, right? No. Give me a second. Where do I put this? I'm not blaming you, by the way. That's just me being not really knowing what's going on as much. Just check back and get graphics. No, where did I put my shaders? Shaders. Oh, they're just in the source. Oh, yeah, right there. Nope, that's the vertex shader. Okay, so what did I do? Oh, I'm going to go back in time. Yeah, so minor improvements to one thing was probably a mistake. There's no need to run blame. Where's history? This, yes, okay. Okay, so this was what I was doing. Fragment shader. View file. Where's the n.l? Oh, this is the shader that Okay, let's figure this out proper. Because I think this is this is even older. This is Alright, so what does n.l do? Right, yeah, before applying... Oops. That's what I was thinking, right? After... Because it's just gonna... n.l. We are doing some kind of, like, cosine or sine reduction. Give me a minute. I'm not the strongest when it comes to my shaders, admittedly. Yeah, I think Ratchet's right. If I had some kind of like emission plus AO, I'd be probably messing it up. Anyway, okay. Let's go back into this. And let's remove that. Okay, let's start from the top. I'm gonna kind of scan this document again because I really want to understand this. Because yeah, this BRDF is literally just ripped from this. That I remembered like probably about when I was looking at this early today, I was like, oh yeah, I left this in here to remind myself that I just kind of stole this from Kronos. So let's concentrate. Yep. Yes, I did base. on the spec. SCB, nice, nice to see you in the stream, dude. Hopefully you're not including me in the talented game devs. I do have no, I'm kind of joking there. I do very much appreciate that comment. If you are referring to me, I think why they don't chase big. For me personally, I don't know, because the industry is a bit opaque. It's not exactly clear what's going on in the industry. So, like, I do know there's a programmer, for example, in my last video, Vulkan. I mentioned him quite a lot. He has been in the industry for quite a while, since the PlayStation 3. So there are like really talented programmers that do, I don't know what you'd call this, content creation, I guess, that exist. But yeah. But then you've got like people like Tokyo Spliff, which is another guy, if you don't know, who does kind of like live stream development stuff, but making his own game engine. And he honestly is, you know, in my opinion, very, very, very good. So, and I don't think he's, that I know of, worked in the games industry. For me, I just want to get as good as possible. I don't really care how I go about it. If that means working with like working in the industry, then I'll work in the industry, but I don't really care to work in the industry as much as improving. So that's why I'm always open to, feedback, and I like to live stream so I can show to myself that I'm being accountable. And, people in the stream can help, like Ratchet was earlier, and Relics. So, very much appreciate that too. So that's just me. I don't know. I just try as hard as I can. Ratchet, with the hopefully you didn't mind me rambling a bit there. Ratchet, with the specification, I'm not sure how strong you are with this particular shader implementation. Do you know exactly why this is bad, right? Because I'm not entirely sure. If I open this up, oops. Let's just open this up. I mean, it had that if statement in that was kind of making some weird gloopiness in really dark areas. But yeah, this was what. And again, this was posted from a book. This was this was effectively, yeah, this, okay. I don't think anyone's going to be familiar with this. I honestly have not looked at this link. It's just honestly a reminder that, look at this thing. Oh no, this is for, oh my goodness, I'm so silly. This is for working out tangent vectors if they don't exist. Okay, I feel very silly with derivatives. Where did I get that was what I wanted. Okay. Did I just copy and paste? Okay, I'm glad I actually looked this up, because it's kind of interesting. Okay, here we are. This is what I meant to look at, right? I was so confused for a minute. I did not know what was happening. Why was I looking at some forum post? So honestly, this is where I picked everything up from. But it seems, I don't know if you would agree, but it seems very similar to this. I don't exactly know off the top of my head what the difference is between these two. But yeah, this is where, this most of this has come from. Yeah, that just caps things to be below, between a range of 0 and 1. Oops, I think I went past it. So if it's, if it's greater than 0, yeah. So it's just like, it's either 1 or 0. I think it saves some computation. There is a this was invented by someone. That's like someone's name. Well, it's part of other, it's part of some mathematical thing. I think we're using Heaviside because there's a lot of talk in the physically based renderer about, sorry, in this code, if I go up to the Fernal mix again, this is visibility. Visibility was V. V is... give me a second. No, that's not right. That's the... roughness. Double A. Yes, we use alpha squared. No, this is... that's the wrong one. Give me a second. Let's scroll down. You don't think that's correct? Yeah. I don't understand. The thing is, when I use this multiplied by my distribution, I don't see any difference, but I guess I'm not using that many materials. How would I check that? I mean, I could find a model with emission and like everything in here, like occlusion and AO. But I think at this point, to test this properly, I would need to have more Vulkan graphics pipelines. The problem right now is I only have one Vulkan graphics pipeline because I haven't piped in any of the old JSON stuff that I wrote to help with building graphics pipelines, which I think I'm going to re-implement. Because we do need some kind of like difference. I definitely feel like I need to go away and study for sure. Oh, heave side. Yeah, sorry, I'm calling it heavy side. Yeah. Yeah. Yeah, my bad. I don't know. These mathematicians' names, dude. I'm not the best reader, admittedly. Right. Okay. So that's the position. Distance. I think for now, am I happy with this? Yeah, I'm starting to think that I should leave this alone for now. We've removed the bug that I was trying to get rid of, which was this. Horribleness. We do have some of this up here. Give me a second. Distribution is the D function, which is this. So multiply. Give me a second. If I denominator divided by pi. A2 is just alpha squared. Alpha squared multiplied by. What is this? Alpha squared. kind of curious actually. What does that do? F5. You can remove all instances of that. I can't imagine it's going to make a big difference. Yeah, that's truly black. Hmm. Mm-hmm. Yeah, let me think. Come on, YouTube. Okay. Got some music playing again. I want to bring this up again. No, this one. And distribution. Yeah, that's the n.h. Yeah, you're right, actually. Why is that not? Yeah, that's just that, isn't it? Alpha squared, which is just alpha alpha. n.h. n.h. Yeah, it's just n.h plus 1. Okay. F5. Let's have a look. Let's have a look. I can't imagine we'll see much difference again, but yeah, like, why was I doing that? Or why was that being done? If I go back to this, this would have been the... Wait, is this just copied and pasted out of here? I don't actually know. The instance of reflection. So what is this for? This is for... So we have distribution. Yep, makes sense. This is the same. I'm just going to increase this for now. So when we come back to it. Alright, let's go back to this again. No. We were looking at... It's not Fernal, it's the D. You know what? I wouldn't doubt Sun Tzu Art of War saying that, Ratchet. Honestly, it's a tough one. BRDF is very finicky. Let's compile a heap, bros. I do use an allocator that does allocate on the heap, so that there is something true to that. I don't know about a 404 error though. I think a lot of my code would have to go wrong for it to connect to a web server to then tell the web server somehow for it to connect to the web server and then it return a 404. But that's what undefined behavior is all about. You never know. With undefined behavior, anything can happen. I like to imagine that if you get undefined behavior, you can technically end up running Skyrim 100% as designed, except there's like one bug in it. There's like one minor difference. Technically possible, extremely improbable with undefined behavior. Yeah, I got to define it, buddy. Yeah, arbitrary code execution in the void engine. Let's go. Next video. Gotta define that behavior. Indeed, indeed. Right. Okay. I don't know, what was I doing? Oh yeah, I was looking up the. Nope, that's my buggy version. Alpha. Where is that being done? There must be a giveaway here, like an alpha times by. Oh, here. Right. Okay. So here we are. That's okay. This makes a bit more sense now. So we get the plussed version of that X. Why is that there? Sorry, for those who don't know, I'm looking at this. I'm just trying to compare it to this distribution here. I'm just trying to work out why it was done in the first place. It might be just a simplified version. You keep getting an error. MySys2. No idea what unfortunately. I only know C++. That might be some kind of C# thing for all I know. So you multiply by intensity after mixing the BRDFs. Interesting. Let's see what that does. I'm kind of curious now. So you mix the BRDFs. So I have Fernal mix, right? So material color. I'm kind of curious actually. Let's see what that does. If I put the, because maybe we're getting like a double factor here where we're like kind of multiplying both together, like twice, and we get like the same variable that we linear interpolate over. Kind of happening. I don't know. Oh no, that's not what I wanted to do. Right. Yeah, because that reflects more closely what this is doing. Because that, it looks like intensity is applied here after the thing. So you definitely, oops, jeez. Let's bring this back in. Except the V function, remember that the filament uses the optimal version of the equation, the results are the same, except the second V function. Ah, right, yeah, of course, yeah. So the second V function. This is the optimal one, isn't it? And I think the fast one. Yes, this. Oh, no, it's the fast one. Which one's the fast one? Oh, okay, then no. What have I done? I've done the. Yeah, I've done the non-fast one. I might implement the fast version actually, until specified otherwise. Yeah, because I have roughness hanging around, right? Oops. Did not want to do that. Ah! In fact, let's just do one thing at a time. Let's figure out how the intensity looks with that change. If it's the same, either way, we've removed a multiplication per pixel. So, whoa, interesting. Oh, idiot. I've I've changed the. That's not anything to do with that multiplication. I changed the intensity, not the range. Yeah, I want bigger range, not insane intensity. Just so so we get darkness all the way to here, but not complete darkness. Yeah, I'm happy with that. There's no... Yeah, that's better. I mean, like I said, we've removed a multiplication at the very least. I don't see any reason why we shouldn't do that. Yeah, let's do the fast one. Let's move into the fast one. So yeah, it just removes some square roots, right? I think that's what it said here somewhere. It's like saves 2 square roots and is good enough for mobile. Right, I'm gonna kind of like comment this out and just kind of like work. See, faster. Sorry, slower. This is just for reference, honestly. Faster. Because I'm probably going to leave the faster one commented out just for reference. But less accurate. And roughness. I think we have roughness somewhere. Whoops. Yeah. Okay. Obviously it's not this simple, just removing a square root. But one step at a time. So we have roughness, right? We have a roughness factor. Is that what we need? I think that's what it's talking about, right? A plus alpha squared. Yeah, I'm just gonna have to rewrite this function from scratch, I think. N.L and N.V. Yeah, okay, so they're the same. Multiplied, brackets, space, and... Oh, why am I doing 2 at the same time? N dot V multiplied by 1 minus roughness, I think. Yes, that's a float variable. Which message? Yeah, one of them got cancelled. I'm not exactly sure which one you're referring to, Ratchet, but yeah, one of them did get deleted. I didn't quite. I don't know why YouTube's doing that. I think I have basic moderation on, but I don't know why it'd be deleting things. Oh, wrong. That's what I get for not concentrating. Okay, so the visibility, assuming that... So you multiply the intensity in the same step. Yeah, I've started to do that. Okay, so yes, that's just the faster version. I likely won't notice any difference with this model. Yes, so... Oh, you do it here. Interesting, okay. Let's... Oops. Ah, no. I want to take this. Thank you. Let's see what that does. F5. Let's see. We have... Oh. Okay. Seems good. So we don't linear interpolate, multiply, we linear interpolate and then we multiply. I don't think it mattered that much, but yeah, we can do that. We can do that. Yes, it did work. Thanks, Ratchet. Do you have top chat or chat all open? What do I have? Oh, I have top chat. Yeah, I have top chat. So live chat's better, I guess. Hi, Rudsash Cian. 1870. Yes, if a car was a game engine, then I'm building a car. No, I'm currently working on a game engine. We are currently debugging my BRDF, which is just a way of like live chat shows all messages. Thank you very much, TT. I didn't know that. It's now on live chat, so all your messages will be seen. So anyway, I am making, yes, I'm currently debugging my lighting. So, because I had this horrible bug earlier today, where I had this kind of like, when things truly get dark, if I turn the intensity down, you'll see what I'm talking about. So if I turn this to 10, save that, and run, I will show you what we're working on. So we've had some success so far where the areas here in the black where you really can't see anything, we kind of had this horrible gloopy effect. Okay, so there's literally no difference. I don't see any difference, at least. That's good, considering the faster version. So yeah, I'm just testing the faster and the slow version of this particular part of this lighting calculation as well. So yeah, that's what we're doing at the moment. Yeah, this is a lot nicer than it was. Okay, let's take a step back and see if we actually are done for now. I think our BRDF is probably good enough. TM. Everything's always air quotes good enough. We've removed a multiplication thanks to Ratchet. We've put that in the same place as the n.l, which is the... What did it say? It said L is the normal vector of the light, and N is the normal vector of the surface normal. Cool. So we have the angle, I think that's the angle of incidence then? No, it's the, yeah, that's the light, right? Multiply it by this. I think the rest of the stuff is just like a different way of multiplying. I think the rest is just shifting around algebra. I haven't seen any like... We've simplified the distribution. We're using the... Yeah, let's bring back the more accurate, the slower version of the visibility, which I'm completely fine with doing. Yeah, I don't really like this. I think I never really got what was going on as much. So yeah, there we go. Certified good enough, indeed. Right, okay, so when I've got to be careful going. I use slow version. Oh, okay, it's not really anything to do with GPUs. Okay, yeah, you know what? I will use the faster version. You are right. I need to think about this, right? I'm always often too conservative, but you know, as I say, Mike Acton said that the hardware is the platform, not the software. I need to be considerate of the hardware that we're working with. If I'm working with like ray tracing ability, you know, ray tracing GPUs and all that kind of stuff, like, it doesn't really matter that I'm spending like a tiny bit longer doing an extra square root operation, because like on the CPU they're like 30 cycles anyway. Oops. Yeah, okay, so yeah, thanks for that. Yeah, I'll come back to tone mapping. I did that as part of a new pass, actually. But that... Also that Reinhardt tone mapping did for me was just make everything less overexposed. And I think it's... I think I was misdiagnosing the problem when I was doing tone mapping a while ago. The only reason that this light is blowing out this this pillar here is because the light is literally like here. It's like, this is where the light is. It's like on the thing, and it's just a generic point light. It's just like literally here. If I moved it to the middle, it would look like normal. It's often like the placement which is causing that. I mean, obviously tone mapping is important, but when I added this, I just kind of grayed everything out a little bit. Again, I could have been using that wrong, but that's what I thought. Yeah, what do you mean, relics? That would be... I'm not sure what you mean by that. I'm going to look at why you discussed that. I'm going to bring up my other engine and just see what would be a good thing to tackle for the a little bit of time I've got left to stream. So for people who are wondering, I'm bringing up my engine. A lot of, if you look at my GitHub, you'll see that this engine is in the README. It's pointing to this, to the Void engine. This one. I eventually want to move all the features that I implemented without the tech debt onto here, like I said in the video. So yeah, in these live streams, I'm probably going to be doing a lot of switching between the engines and slowly implementing new features that I had in the old engine without all the silliness. That's the theory, anyway. So what I want to do here is, yeah, basically I think I've talked about this like thousands of times on stream, but the next steps are to improve assets, handling assets via going bindless. Now I've definitely turned on bindless textures already, like we do have that activated, but we're not using it. And I'm just going to have a little dig around in my other engine to see what was going on, what is the difference, because I do have both code paths here, which is useful for debugging, I guess, but irrelevant for desktop GPUs. So right now I'll have things like this. That's the set index, isn't it? Yeah. That's the descriptor set index. We don't want to do that. What I'm interested in is... Okay, so bind descriptor set. Okay, what descriptor set are we binding then? Vulkan bindless descriptor set cache. It's a bit of a mouthful, but it looks like that is what I did. Resource update. What is this? It's peak. Okay, so this is just resource update. Oh, okay, so this is for the queue. Okay, interesting. So we're going to update this in a queue. Yeah, to be updated. So this is going to go in a queue. This is a queue. Deleting 0. Okay, interesting. Current frame, sure. So we are using a handle, no problem. Okay, fine. Okay, so how do I begin implementing this without rewriting everything? Yeah, so I'm gonna unfortunately have to read a bit of code. So when you were talking about bent normals, you said in essence, so this is relics. So in essence, it removes specific channel AO from the MO AO. Okay. Channel packed physically based rendering to combine AO and normals. Oh, so it bends the normals, I see. Or something like that, like moves them. Oh, interesting. You know what? That's super interesting. I'm gonna have to look that up. See, live streaming is really cool. You get to get exposed to all sorts of cool new things. Yeah, definitely gonna have to look that up. Okay. Skip bindless. So this skips bindless. Okay, so if skip bindless is true, then we just continue. Really? So we're filling up a... Are we filling up... We must be filling up a second buffer or something. Yeah, 1 minute, guys. I'm gonna have to go AFK for like a few seconds. Okay, I'm back. Just had to nip to the loo. Okay. Right. Next step. Figure out what to do. Yeah, this might be a bit ambitious to start coding this immediately, but because I don't have as much time to stream today, but we can at least start. I think this will be the next objective. Because we definitely need bindless. It just makes everything easier. But the setup isn't trivial. So yeah, what I'm doing at the moment is just reading. Okay, so Relics has sent me a bunch of really interesting stuff. Okay. Sorry to interject into your conversation between Relics and Ratchet. It's really interesting. This like you can. All right, I'm gonna have to look up look at what you guys are talking about as well. Oh, there's so many fun things to learn. Okay. But yeah, we need to professionalize my engine a bit before I get carried away. Okay. Where is this? This is at the beginning. This allocates a descriptor set that's going to be used as part of a descriptor set layout. So we have a bindless descriptor set layout. Interesting. Oops. So this means the set must be... The set index is 0? What? Does that mean... Alright, I've got to see this descriptor set layout. What? Sorry, not the descriptor set layout. I need to set up the... So we have bindings... This is 10 and 11. So this is 12. And the max spineless resource is 100 and... So when we set this up, we are going to have a type, sure. Next image... I think that's just poorly named. Oh, new image, sorry, new index. What am I saying? New next image. Total and for a binding. Sure, so I should, if I go in these shaders, I should see for bindless textures, I believe 11, is it 10 or 11? I've forgotten. So 11, a 10 and 12. Which are actually the things that we're actually writing to. Brilliant. I will do Pano's Spartan engine. I will Google that and see where we're at with that. So Pano's... engine. Let's see. So I assume this is it. So Pano's K92. Oh nice, this is way further on than mine. Nice, this is really cool. Thanks, I will bookmark that. And yes, cool. Weird. I must have a local server version that isn't down for me. Okay. So I need to look at my shaders to see what the descriptor sets are. I think it's safe to be in... hang on. This will be in a header. instead, I think. Material set. Might be 1, I think this is I think we have a different descriptor set. Mesh, maybe? Okay, here we are. Okay, so we have mesh instance draw. Mesh bounce. Oh, this is part of this material set. I think that is different from what we're looking at. I think bindless is... If I find that, I have a feeling that we're going to see that as a 0. Sorry, this is a 1. Where is the platform? Yep. Okay, so global set. Ah, here we are. This is what I wanted to see. So we have a uniform, global buffer. Yeah, global thingamajigs. 3D. Yeah, this is like a cool. What is this? Oh, yeah, 10, 11. Okay, that's cool. That's what we wanted. This makes total sense so far. Right only. So we... okay, so we have a descriptor for writing out things. And we have a... Ugh, why did I do that? But yeah, this is part of a different... or what is it called? Descriptor set layout, that's the one. And this is only in... Let me think. Yep, so 2 different descriptor sets, layouts, descriptor set here. Yeah, I guess that makes sense. I'm going to be binding the descriptor set that's going to be pushing up, or not bind. No, it's bindless. It's not quite that. We're just indexing into an array of images. That's why this is here. Sorry, textures. So samplers in this case. And when we bind, what are we doing when we bind? So this is us writing to it, because we need to, if we're going to have a descriptor set, we need to write to it. Likely a image sampler layout, because why wouldn't it be? If we're uploading a sample, but the bindlessness of it, so I'm just trying to reverse engineer my in a way. Okay, that's a bit of an exaggeration, that, but I'm just trying to figure out what I want to do versus what I did in the past. Yeah, homework I'm getting. Yep. Isn't it? Well, that's the thing with graphics. It just never ends. Like, yeah. For example, Relics has just brought up a really good point, right? So there's a VK descriptor heap, and I believe that's the one. I could be wrong, but that's like a completely different way of doing descriptors. So there's a lot. There's always stuff to learn. And I think this is why like Vulkan is so intimidating to people, because they'll go on Vulkan tutorial and it'll be like, they think they've got it down, but then like there's all sorts of stuff that you need to do, and what you've built there isn't exactly what you want, etc. And it goes on and on and on. Like I've built a query timer for my GPU, and I think Relics pointed out that that kind of destroys the in itself. When I was doing that, what am I doing? I'm basically querying the GPU with Vulkan, with a particular command that unfortunately is not good enough for profiling. So I get like inaccurate results. So there's always stuff. OpenGL. Sorry, so to answer your question. So, Sinful Bobcat, sorry. Welcome to the stream. Thank you for joining. What would you suggest for complete beginners? I think people have a lot of different things, a lot of different opinions. It depends on what your goals are and what you want to make. Like, if you want to make a game engine that's got like really nice graphics and you're willing to spend years learning this stuff, then the amount of the beginner curve, the learning curve of Vulkan isn't going to be that much of an issue because you're just going to be spending so much time on it. If you just want to make like a cool little tiny little game with not much going on, graphically speaking, then you might have an easier time with OpenGL. Either way, graphics is just difficult in general. I think anyone in this chat will say, yeah, so for example, this guy, yeah, I've just learned about this game engine called the Spartan engine, and he's been working on it for 10 years. I've been working on this variation of this engine for 2 years. So that just puts in perspective, hopefully, that if you're in it for the long haul, like, Vulkan might be an option for you. But if you just want to make, like, I don't know, something really simple like a 2D top-down game, you could probably get away with OpenGL. OpenGL will eventually not be supported, but I still think that's going to be a long way away. I don't think that OpenGL is going to be dropped by any driver anytime soon, considering they've already done the work. So yeah, it really depends. Yeah, I'm always having to learn. The thing is with graphics in general, even with OpenGL, in my opinion, I'm always having to learn, like, every day. That's just me though. That you don't have to be as hardcore as that, but no matter how good you get, there's always room for improvement, no matter what. There's like weaknesses that I have in my programming. It's just so, hopefully I haven't made it too intimidating that you don't want to start. I'm just saying that, it depends on your goals. Hopefully that's been useful. So yeah, let's at least start writing the descriptors up. Which I'm just going to stick with regular descriptors, not going to try anything fancy. Descriptors to me aren't that bad. They're fine. You just make a layout, then you just allocate them out the layout, bind them at the right time, done. And I'll obviously update them before you bind them. And bindless kind of takes away some of the headaches of having to have a limit of how many things you can bind and all that kind of stuff. So right, what do I want to do? I want to go back to my I had it open before. I kind of clicked around. No. Shaders. Yep. Okay, so let's... Now for my descriptor sets, I need to think. If I go bindless textures first or bindless descriptors? I think I should go bindless descriptors, because otherwise I'm going to have to write bindless... Oh my god, this is so silly. So if I go bindless descriptors and then I don't go... Yeah, okay. Let's not write the shaders first. What is this? Okay, let's dig into this a bit. I'm probably going to just do some revision off stream tonight and tomorrow about what I really need to do. Yeah, go bindless descriptors first, yeah. Okay, so you want to make a one big descriptor set to rule them all. You're trying to get a small 3D open world RPG like Zelda type graphics using Unreal or Unity. Using Unreal and Unity doesn't provide me with the control nor the performance goals. So I started learning about engines. You know, a good project to try if you've never done this before. It's probably not. It's just an idea. I'm not saying you should do it. Is build a Minecraft clone. That is honestly a really good project to start with. It's voxel based, so it simplifies so much of the work that you need to do. There is some stuff that won't carry over, like voxel like height map generation and stuff like that. But if you can build like a Minecraft clone, that'll give you like an idea of like how the graphics APIs work, while being limited to a 3D game that's not as complicated as like a full, like a Zelda-like game that you're after. Sinful Bobcat. But yeah, that's just a suggestion. You don't have to take it, because that's what I did. I started off with a Minecraft clone. You can see that on my YouTube channel. It's like an old video of really loud music, blasting with a okay. I think for the most part, yeah, I'm gonna have to unfortunately cut this short. I wanted to keep going, but yeah, something's come up. So thanks for tuning in, guys. Honestly, it's been a pleasure as usual. Hopefully you've enjoyed your time here and not been too frustrated by my incompetence. No, honestly, it's always nice to hear everyone in chat talking about things and teaching me things as I go. So yeah, I'm gonna call it here, guys. Hopefully you have the good rest of the day. No problem. Glad you can turn up, TT. Yeah, brilliant. Yeah, Minecraft clone is great. Yeah, honestly, brilliant. Yeah, brilliant. You know, honestly, thank guys. You know, it's very much appreciated you all turning up. So I'll see you in the next one, guys, and yeah, have a good rest of the day.